Okay, this morning I'm going to be teaching you probably in the top 5 most important lessons of the year, what is slope or rate of change. When you hear the word slope or the word rate of change, these basically are the same, mean the same thing. Now what slope is it's basically telling you how the line is tilted. Okay? And hopefully by the end of this lesson, when you see the number that's the slope, you'll be able to tell me a little bit more about the equation of the line. Okay, so slope is the change in y over the change in x. Now the first mistake people make is they put the change in x over the change in y. I'm not going to get into this lesson right now why it's y over x, but it's how much the y is changing versus how much the x is changing. It's a ratio basically, it's a fraction. How much the y is changing versus how much the x is changing. It's a number, okay? So for example, you don't have to write this in your notes, but if I said the slope, and the letter we use for slope is m, okay? But if I said the slope was 1/2, then I'm saying the first number, the top number tells me to either go up or to go down. The bottom number either tells me to go left or to go right, okay? So when I see 1 over 2, is 1 positive or negative? It's positive, so it's telling me to go up 1. The second number, the 2, is it positive or negative? It's positive, so it means to go right 2. Okay? So when you see a slope, it's going to be a number. The top of the fraction tells you to go up or down. The bottom of the fraction tells you to go left or right. Okay? So the best way to first learn this is the equation for the slope, but I'm not going to get into that right now. We'll get into it later. Okay? But if you had an equation of a line, or I'm sorry, if you had the actual graph of a line, and I asked you to calculate the slope, this is all you're going to do. Find 2 points that you know are on the line. So in this case, I use that point, which is the x-intercept and the y-intercept. Okay? So I have those 2 points, and let's see what are their names. -2, 0, and this one is 0, 0, 3, right? Okay, so those are 2 points that are no on the line. Okay, remember, slope is up, down, over, left, right. It's a fraction, right? I always start with the left-hand point. Okay, start with the left-hand point. To get from this point to this point, do I go up or down? Well, I go up, right? How far do I have to go up? 1, 2, 3, right? So I went up 3. So I went up 3. And then I went, do I go right or left to get there? Where in this case, since I started with the left-hand point, I would go right, yeah? So I would go right 2. Right 2. Up is positive, so it's positive 3. Right is positive, so it's positive 2. 3/2. The slope of this line is 3/2. It means for every 3 you go up, you're going to go right 2. What a slope really is, if I really wanted to dumb it down, a slope is directions from one point to another on the graph. If I go up 3 and right 2, I will be on the line. Watch this. I went up 3, right 2. I'm on the line. Let's do that again. Let's go up 3 again. 1, 2, 3. I go right 2. Look at that. I'm on the line again. Go up 3, right 2. I'm on the line again. What you'll see is these little stairs. Okay? Which is why we call it rise to run. All right, you have to see these little stairs. Up 3, right 2. It's basically just directions from one point to another that are on the line. Okay, now question, how do I get points that are down here? I can't go up 3 because that'll take me up here. All right, how would I get to these points? Well, the other way I could have gone is, instead of going up 3, right 2, what if I started with this point? Then I could have gone down 3 and then left 2, right? I could have gone down 3 and left 2. Now down is negative, so that's negative 3, and left is negative, so that's negative 2. Now a negative divided by a negative is a positive. 3 halves again. No matter if I start with the left-hand point to the right-hand point or the right-hand point to the left-hand point, I will still get the exact same slope of 3 halves because it's the exact same line. So that is how I generate points down here. Instead of going up 3, right 2, I'm going to go down 3, left 2. So that's what I'm going to do. Go down 3, 1, 2, 3, left 2, 1, 2 on the line. Go down 3, 1, 2, 3, go left 2, 1, 2 on the line. 1, 2, 3, left 2 on the line. All the points of the line. Real simple. All right? Now let's do example 2. Let's do the same thing again. In this graph, remember we like starting with the left-hand point. So here's my left-hand point. To get from this point to this point, remember the top of the fraction is up or down, and remember m is slope. It's up, down, over, left, right. Okay? Do I go up or down to get from this point to this point? Well, I go down. Down how far? Well, down 1, 2, 3, 4, I believe 5, right? 1, 2, 3, 4, 5. So I went down 5, and I went right 3, right 3. So I went down 5, right 3. You must write that, okay? Down 5 is down positive or negative. Down is negative, so it's negative 5. Over is right positive or negative. Right is positive, so it's positive 3. The slope of this line is negative 5/3. That tells me if I go down 5, right 3, I will be on the line. Let's try it. Down 5, 1, 2, 3, 4, 5, right 3, on the line. Okay? On your homework tonight, I didn't mention this yet, but the slope is negative 5/3, which is down 3, down 5. Let's fix that. Down 5, right 3, or up 5, left 3. The opposite of going down is up. The opposite of going right is left. Both of these work. When you write your homework tonight, when you do your homework tonight, you need to write it all 3 ways. As a number, as directions going down, and as directions going up. So afterwards, let's graph those points. We went down 5, right 3, we're on the line. Let's also go up 5. 1, 2, 3, 4, 5, right, left 3. 1, 2, 3, we're on the line. See it? Go up 5, 1, 2, 3, 4, 5, go right 3, I'm on the line. There it is again. Okay? So let's go back to this first example again. So when I'm done, I would need to write it as the slope as a number. So the slope is 3 halves, which is up 3, right 2, or down 3, left 2. And that's your final answer, okay? All right, so example 3. All right, let's do it the same way as before, and then I'm going to show you a quick little formula you can use to find the slope quickly without having to graph it. But let's graph these 2 points. Negative 4, 2 is here, right? And 2, 6, and 2, 6 is here, right? Okay, so to get from this point to this point, because remember I always start with the left-hand point, to get from this point to this point, do I go up or down? Well, I go up, how many? 1, 2, 3, 4, up 4. And then I go right, how many? 1, 2, 3, 4, 5, 6. Right 6. So the first way I could do this is I could say the slope is up 4, right 6, which is up is positive, so it's positive 4, and right is positive, so it's positive 6. Now be careful with this because 4, 6 can be simplified to what? 2/3. So the slope of this line is 2/3, which means positive 2 means up 2, right 3, or down 2, left 3. Okay? Now, One way you can find the slope is to graph the 2 points and move from point to point. But there's another way to do this. And if you go back to your notes at the very beginning, I said that slope is equal to y1 minus y2 over x1 minus x2. When I subtract the y's from each other, what I'm basically doing is finding the distance between these 2 points. And when I subtract the x's from each other, I'm finding the distance between the x points. So when you see y1 minus y2, that means how far between the y's, and then x1 minus x2, how far between the x's. All right, so in your notes, another way to do this, the quicker way to do this, is you don't want to have to graph the points each time and figure out how far between them. What you can do instead is use the slope formula. Okay? Every time you do, so if they give you 2 points, I want you to do it this way. Write the slope formula. Slope is equal to y1 minus y2 over x1 minus x2. Okay? Pick one of the points, call it the first point. So this is x1, y1, and this is x2, y2. And then all you do is you fill in the blanks. It's quite easy to do. It says y1, so what's y1? 2. 2 minus, minusing what? 2 minus y2 is 6, so 2 minus 6. x1 is negative 4, so it's negative 4 minus x2 is 2, so negative 4 minus 2. Okay? 2 minus 6 is negative 4. And negative 4 minus 2 is negative 4 plus a negative 2, so that's negative 6. I get a negative over a negative, so let's simplify this. Negative 4 over a negative 6. Now, first things first. A negative divided by a negative is a positive, so this answer should really be positive. And 4/6 is really 2/3. So it's positive 2/3, which is exactly what I got doing it this other way. Now you need to get away from graphing it, because what if these points were not pretty points? What if they were fractions? What if they were decimals? You couldn't graph them to find the slope. This method will always work because all you're going to do is do some quick little subtraction problems. Okay? So the slope of this line is 2/3, which means positive 2 means up 2, positive 3 means right 3, or opposite of up is down 2, opposite of right is left 3. Same exact thing either way. But if they give you the points, the way I want you to graph the way I want you to solve these is by using the slope formula. Now here's something interesting. What if instead of calling this one x1, y1 and this one x2, y2, what if I called this one x1, y1 and this one x2, y2? Well, what would have happened differently? Well, I'm going to do this off to the side so you can see it. But if I call that, if I flip them around, then I would have had 6 minus 2 over 2 minus a negative 4. Now 6 minus 2 is 4, and 2 minus a negative 4 is 6. I get 4/6, which is still 2/3. So it doesn't matter which one I call the first point, because I'll end up with the exact same slope either way. Okay? Let's try it again with example 4. We're going to go a little bit faster now. All right. Find the slope of this line. If they give me the 2 points, I'm going to use the slope formula. So slope equals y1 minus y2 over x1 minus x2. Okay, label your points. This is x1, y1. This is x2, y2. And it doesn't matter which one you call x1, y1. You'll get the same answer either way. Okay, plug in the points. We get 2 minus a negative 1 over 5 minus 4. 2 minus a negative 1 is 3. And 5 minus 4 is 1. Now, this time, 3 over 1 is really what? 3. The slope of this line is 3. So the slope of this line is 3, which means what? It's 3 over 1, right? Which means up 3, right 1, or down 3, left 1. And there's your answer. Okay, now let's do another example, example 5. And in this problem, I'm actually going to show you something new and different. All right? Let's go ahead and do the slope formula for this, which is m equals y1 minus y2 over x1 minus x2. Fill in the blanks. Remember, label your point. So this is x1, y1. This is x2, y2. Y1 would be what? 5 minus 5 over negative 3 minus 4. Okay? 5 minus 5 is 0. And negative 3 minus 4 is negative 7. Okay? Okay, so 0 divided by negative 7. This is kind of weird. So what is 0 divided by negative 7? Well, if you have a calculator out, if you can get a calculator out, go ahead and try this. And since you're on a computer, you probably do have a calculator out. So 0 divided by 7 negative equals 0. So 0 divided by a negative 7 is actually 0. And that makes sense logically if you think about it for a minute. How many negative 7s can you take out of 0? Well, none. So the slope of this line is 0. Now, what does the slope of 0 look like? Well, if I was to graph those 2 points, negative 3, 5, and 4, 5, what do you notice? These 2 dots are horizontal to each other. When the line is horizontal, when the graph of this line is horizontal, which it is in this case, the slope of that line is going to be 0. Okay? So when the top of the fraction is 0, the answer is going to be 0. Okay? So what's the slope of this line? The slope of this line is 0, which means up 0, right 1, or down 0, left 1. Then we have the second special case. So go first things first, write your equation. Slope equals y1 minus y2 over x1 minus x2. Label your points. x1, y1, x2, y2. Plug them in. This is going to be 2 minus a negative 3 over 5 minus 5. Well, 2 minus a negative 3 is 5, and 5 minus 5 is 0. Now, you may be thinking 5 divided by 0 is 0, but if you have a calculator, let's go ahead and try it with a calculator. Let's do 5 divided by 0, and it says cannot divide by 0. What does that mean? How many zeros can you take out of 5? Well, as many as you feel like, and you still have 5. So I'd say 5 divided by 0 is 12. And then how much do I have left? I still have 5. So I take out another 5. I can do anything I want. 5 divided by 0 is any number I want it to be, and I still have 5, and so I can divide again. I can divide again. This means, what number is it? 5 divided by 0 is really infinity, but in our case, we're just going to write undefined. It's really infinity. 5 divided by 0 is infinity, but we're just going to write undefined. If it's undefined, you don't have to write it in words. The slope is undefined. So let me summarize this really quick between these two. If the numerator is 0, the answer is going to be 0, which makes a horizontal line. If the slope is undefined, what does that mean about the graph? Well, let's look at the graph real quick. Let's graph those 2 points. 5, 2 is here, and 5, negative 3 is here. What do you notice about these 2 points? Well, hopefully you notice that they are perfectly vertical to each other, right? And that's a very important concept. Those 2 dots are vertical to each other. And remember one of the very first lessons of the year on functions. And I told you, if 2 dots are vertical to each other, it's not a function. This is one of the reasons it's not a function, because when two dots are vertical to each other, the slope is undefined. We don't have math that can explain it because the slope is actually infinity. We don't have a way to explain that. So because we can't explain it, that's one of the reasons it's not a function. Two dots that are vertical have a slope that is undefined, which means our math breaks down and we can't solve it with simple math or simple algebra. Okay? So top is equal to 0, the slope is 0, which means it's a horizontal line. If the denominator is equal to 0, it's going to be undefined, which means it's a vertical line, and that's not a function. Okay? Hope that makes sense. All right. Example 7 and example 8 are kind of interesting problems because in this case, you're saying this. You're saying, what number do I put in for x so that when I take those 2 points, that their slope will be negative 2/3? Make sense? So what I would have you do is first write the equation like before. Slope equals y1 minus y2 over x1 minus x2, right? And just plug in what you know. Do I know the slope? Yeah. Well, it's negative, oops. The slope, I know this time, so it's negative 2 divided by 3. You can make either part the negative. You can make the whole thing negative, the 2 negative, or the 3 negative. I'm just going to make the 2 negative to make my life easier. Equals, well, I'm going to call this x1 and y1, and I'm going to call this x2 and y2. Okay? So plug it in. y1 is what? 2 minus 0 over x minus 3. Simplify it. I get negative 2 over 3 is equal to 2 minus 0 is 2 over x minus 3, right? How do I solve this? Well, remember, this is a proportion, basically, and I can cross multiply. So I would butterfly this, right? This goes together, and this goes together, and you could do that because of algebra, all right? You would have negative 2 times x minus 3 is equal to 3 times 2 is 6. Now I could distribute that negative 2 to both things, or I can start off by dividing both sides by negative 2, and that's what I'm going to do, is divide both sides by negative 2. Those cancel. I'm left with x minus 3 equals negative 3. Add 3 to both sides, and I get x equals 0. What does that mean? Well, if x was 0, then I would have 0, 2 as a dot on the graph, and I would have 3, 0 as a dot on the graph. And what's the slope of this line? Well, I'm going down 2, right 3, which is negative 2/3, which is exactly what I wanted it to be. Okay? Last example. First things first, I want to figure out what does y have to be to give me a slope of negative 2? Well, first write the equation. Slope equals y1 minus y2 over x1 minus x2, which becomes negative 2 equals x1, y1, x2, y2. So I would have y minus a negative 4, which is plus 4, over 0 minus 5, right? So I end up with negative 2, negative 2 is equal to y plus 4 is y plus 4 over a negative 5. Now I could distribute that negative 5 to both things, or I could start off by multiplying both sides by a negative 5. And that's exactly what I'm going to do. Sorry. Start off by multiplying both sides by a negative 5, right? When I do that, negative 5 times negative 2 is 10, so I get 10 is equal to, those cancel, they make 1, and I get 10 is equal to y plus 4, right? All right, so I get 10 equals y plus 4, so add a negative 4 to both sides. 10 plus a negative 4 is 6, and I get y is 6. So I'm saying if y is 6, these 2 points will have a slope of negative 2. So let's try that real quick. 0, 6 is where? 0, 6 is here. And 5, negative 4 is here. And how do I get from this point to this point? Well, I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I go down 10. Down 10. And I go right 5. Right 5. Well, down 10 is negative 10. And right 5 is positive 5. And negative 10 divided by 5 is negative 2, which is exactly what I'm saying. It works. So there you have it, slope and rate of change. Let me summarize this real quick. Rate of change, the other words for rate of change are rise to run, and rate of change and slope are 3 words that all mean the same thing. And this is my personal one, up, down, over, left, right. So slope, rise to run, and rate of change, they all mean slope, and they're some of the most important words in Algebra 1 and in all algebra. In fact, when you get to calculus someday, you're going to be dealing with slope a lot more, and it's a very, very important concept. Make sure you get this down. Make sure you understand what it means, because you'll be using it for years to come. Good luck.